Hello 8th graders, in this IXL video lesson we're going to be looking at assignment I.1. Cluster I is about proportional relationships, and the first assignment I.1 is about finding the constant of proportionality from a table. So we're going to click into that assignment, and as that's loading we're going to display some notes as usual on the screen. This assignment, as you can see from the title, is about finding the constant of proportionality from a table. And we are going to start taking a look at proportional relationships, which is where this idea of constant of proportionality comes from. So first we really need to know what a proportional relationship is. And that's any relationship between two variables, two quantities, where y and x maintain the same ratio to each other. So in this example, our y is the number of pitches that somebody throws, and the x is the number of tokens that they put in. So every single proportional relationship is going to be looking at how one quantity compares to the other. And in this first example's case, we're going to look at the number of tokens that Tammy has compared to the number of pitches that Tammy gets. And the constant of proportionality is just measuring that constant ratio between y and x, and we find it always by doing y divided by x. If something's proportional in a relationship, that means whenever you take whatever the y is and divide it by x at that point in time, it always spits out the same ratio, or the same number of y's per x. So let's read through this question here. It says, because Tammy and her dad share an intense love of baseball. Every weekend they go to the batting cages to practice hitting. Tammy's dad buys tokens for her to use in the batting cage. And we're told there is a proportional relationship between the number of tokens Tammy uses, which is x, and the number of pitches thrown by the pitching machine, which is y. And we see some data here. If she has 1 token for x, she's going to get 5 pitches. If she has 2 tokens, then she's going to get 10 pitches from that machine, and so forth. And when we have a proportional relationship, that means y divided by x at any single point is going to ultimately give us the same ratio. So in blue, I'm going to take this first one. We have 5 to 1. And if I were to do 5, this is going to be a bit messy, but 5 divided by 1, 5 pitches for every token, then that doesn't really have to simplify at all. That means that stays at a ratio of 5 pitches for every 1 token. So go ahead and say 5 pitches for every 1 token. And that's all this 5 to 1 ratio here means, is that for every token she gets 5 pitches. Now if we had tried a different point, let's go ahead and switch color. Maybe we'll look at the third row. And in this third row here, we see at 3 tokens, she has a total of 15 pitches. And because this is proportional relationship, any data point I pick from this table, 15 divided by 3, that's going to give me the same ratio of 5 over 1. 15 divided by 3, when I simplify that fraction, or when I do 15 divided by 3, that simplifies to 5 pitches for every 1 token. So all this assignment is really asking you to do is to, Mr. Neville would have called this the unit rate last year. It's if we have this proportional relationship, how much is our y for every 1x? Or in this case, we're going to get 5 pitches for every 1 token. No matter how many tokens we buy, we'll get more pitches, but it's always 5 pitches for every 1 token. You're going to give me a second here to clean up my screen, because there's a lot of mess there. Alright. And now this time, we're given a new relationship, but all of these in I.1 are going to be proportional tables where you just have to find this constant ratio of y over x. Now we have Jake, and Jake is filling water bottles between classes, but the water fountain's slow. So we see, hey, he gets 3 ounces of water from that fountain in 6 seconds, and it maintains the same ratio as we go through. So if I were to take the first example, we'll go ahead and switch to a blue color here. If I look at this first row, in 3 ounces of water, it took him 6 seconds. So if he pours for 6 seconds, y over x, remember we always do y compared to x, then we simplify to be 2 over 1. 6 divided by 3, or 6 seconds for every 3 ounces, is the same thing as ultimately 2 seconds for every 1 ounce. So we go ahead, now we've changed our units, we're down to seconds, and the y value is seconds the X value is measuring, ounces, and we'll go ahead and drag those in there as well. So this ratio of 2/1, or a constant of proportionality, means it takes 2 seconds just to get 1 ounce of water. And we see from any other data point, we'll go ahead and pick the last data point here. And this last data point tells us Jake gets 9 ounces in 18 seconds. And if I were to do 18 divided by 9, 18 seconds divided by 9 ounces, I'm going to get that same ratio. 18 divided by 9 gives me that same 2/1 ratio. 2 seconds for every 1 ounce. So that's the answer they're looking for here, a ratio of 2:1. And at this point, we're going to skip ahead because a lot of this is just having you do y divided by x. So we're going to skip ahead a little bit. Thank you for the patience. And we're going to jump a couple levels. Find one that's a bit more difficult. Now, as we move on, later in this assignment, they won't guarantee you have a proportional relationship. Instead, they'll ask questions about whether or not the table shows a proportional relationship. And here, I'm going to put a purple box around this question. And the question at the end, after they give us the info about Jill and her friends, says, according to the values in the table, do X and Y have a proportional relationship? And remember, proportional relationships are relationships where y and x maintain the same ratio to each other at every data point. Y divided by x should always spit out the same constant of proportionality if you do have a proportional relationship. So I'm going to go ahead and test here. We use different colors to test. In the first one, we'll test this first row. 11 divided by 1, 11 miles every 1 hour. We don't even need to simplify that. That's 11 miles for every 1 hour, and we're good to go at that point. I want to test another one, see if it spits out that same 11:1 ratio. So in the third row, we could try 66 miles. So Jill, on her fishing trip, goes 66 miles, and that took her 6 hours. And if I simplify that, any ratio is just a division problem, and 66 divided by 6 gives me 11, or 11/1. I get that same ratio here, and we'll go ahead and put in our units, of 11 miles for every, let's make that smaller, 11 miles for every single one. In this case, we're measuring hours. So that's all this ratio means. When I do the 66y divided by the 6x's, it's really telling me, hey, I'll get 11 miles, that's what the y measures, every 1 hour. And if I did the other ones, 44 divided by 4 also gives us 11/1, 77 divided by 7 also gives us 11/1. Because all of these y divided by x's maintain the same constant of proportionality, then we can confidently say, yes, this is the type of example that is a proportional relationship. And towards the bottom, they say we'll move down. What is the constant of proportionality? Write your answer as a whole number or decimal. We see it's just 11 miles per hour, that ratio we came up with. And for this next problem here, we see again they're going to be giving us a table with a relationship. This time the table's measuring the relationship between the number of tickets X and the cost in dollars Y. And they say, according to the values in the table, do X and Y have a proportional relationship? So again, I'm going to do some X divided by Y's to try to see, does this give the same constant ratio at any point? So the first one I'm going to test, I'm going to go ahead and test, put a red box around this first one here. It says 21 divided by, $89.21 tickets. So I'm going to go ahead and put 89 in the numerator, and I'm going to divide that, the Y value, by my X, 21. And if I do 89 divided by 21, I'm going to use this Google calculator up here. Google's toolbar is a calculator anytime I want. And 89 divided by 21 doesn't simplify, but it does give us a ratio of 4.238. So I'm going to go ahead and put that about 4.238 here. And sorry, that's messy. And now, if this is truly proportional, this table, every y divided by x should create the same messy ratio of 4.238 ... to 1. So I'm going to go ahead and test a different data point here. We'll switch our color over to purple. We'll put a purple box around the third data point. At $95, we had 24 tickets. So I'll go ahead and set that up over here. $95 divided by 24 tickets. And if we have a different ratio than we saw in red, that tells us this is not proportional. I'll go ahead, use my calculator again to get an answer because this is getting messy now. And we see that I get a decimal of 3.958. I'm going to just put 3.9 to make my life a little easier. Because at this point, once I see something that's not 4.238, I know these are different ratios of y to x. And that tells me that this table is not a proportional relationship. Not because these decimals are messy or anything, but because the ratio is not staying at the same constant proportion. It's a different ratio at different points in time for this table. So this is something that's a bit more complicated than a proportional relationship. There's a little more going on here to determine the price. This video has gone quite a bit. If you're still struggling towards the end of this video, I would strongly encourage you to send me an email. And my email is on the screen now. That's at the bottom. It's ddoherty3@bostonpublicschools.org. So please send me a GChat, send me an email if you're struggling on assignment I.1, and I'm happy to work with you one-on-one there. Thanks for watching to the end of the video. Hope it was helpful.